Hi everyone. Today is a day where I am a student and I get to observe a couple other classrooms, so I am not here today. But today we're going to be working on solving special systems of linear equations. They're special because they have a special number of solutions. So let's get started. First of all, just to review, we learned 3 different methods before break of solving different systems of linear equations. The first one was graphing, where we were able to graph 2 different equations and then find their intersection points. So here I would have my y-intercept of 2, go up 3 over 1, or I could go down 3 back 1 for the first equation. The second one, I would start at a y-intercept of 6, and then I would go down 1, 2 over 1, and then find their intersection point for the solution, right? Otherwise, there was another method that we learned, which was called substitution. This is especially useful when you have an equation solved for another variable. So if you look at the first example, we were solved for x, which means we could plug this expression in for x and then solve for y. The third method that we learned was elimination, and this is the one that most of you liked the best, especially when we had systems of equations that was lined up. So y's were above y's, x's above x's, numbers with numbers. In this case, you need the same number but opposite signs. I see the same number with my y's, but they're not opposite signs. So if I were to multiply this first equation by, a negative, it's going to change all of our signs. And then I can add my 2 equations together to cancel out a variable. And then I would solve for x. Right? So just a review of the different methods that we learned. We're going to be using these to help us solve these special systems of linear equations today. And hopefully when we do an example, this will make sense. So let's turn the page. This is going to be our first example of the day. I notice that immediately I have a y equals equation. So we have y by itself. So I'm going to use substitution. In this case, instead of writing y, I'm going to plug in this new expression, x minus 4, for y, and rewrite my expression. When I do that, I'm going to combine like terms. Negative x plus x is equal to 0. That's kind of weird, right? In this case, all variables canceled. Is this a true or false statement? If you remember from previous chapters, when we had these true or false statements, they either gave us no solutions or infinite solutions. So true would give us infinite solutions, and false gives us no solutions. In this case, negative 4 is not equal to 3, which means this is false, so I have no solutions. If you remember from a graph, no solutions was an example where we had 2 different parallel lines because they never intersected, right? This is the way that we end up with no solutions by solving. Next up, I want to go through an example of where we might get infinite solutions. So this next problem I see is also solved for y. We have y by itself, which means I'm going to use substitution to solve. In this case, my y is 3x plus 2. I'm going to replace the y with 3x plus 2. And when I do that, Don't forget to use parentheses when you plug in this new expression, because you're going to notice that I have to distribute the negative sign to get 3x minus 2 plus 2, and all of this is equal to 0. Once again, you're going to notice the same thing happens. 3x minus 3x is 0. And then I end up with negative 2 plus 2 equals 0. And isn't negative 2 plus 2 0? Since this is a true statement, you're going to get infinite solutions. Hopefully that makes some sense, right? It's very similar to what we did in previous chapters with inequalities, where your variables canceled out and then you have to assess, is this true or false? And then that will tell you if you have no or infinite solutions. If you remember, for infinite solutions, that was where you graphed, two of the exact same line. Because they cross an infinite amount of times. All right. So those were two different examples of how you're going to solve special systems of equations algebraically. And then I want you to remember what this looked like on a graph. We sort of talked about this in 5.1, so you might want to refer back to your notes with this. These classifications, I don't need you to know it. I'm not going to ask you on a test. So whenever you see classification in your notes, I don't need you to worry about that. What I do need you to worry about is if you can decide how many solutions there would be and then what that looks like on a graph. And we already wrote this down in section 5.1. So if you have this in your 5.1 notes, you don't have to worry about it. If you do have this, or you do not have 5.1, written down, then you can write this in your notes. All right, so let's go through a couple of examples just for good measure. In this case, I have two different problems, and it doesn't look like I have a variable perfectly solved for x or for y. So what I think I want to do, I'm going to do elimination. But first, I need to make sure both equations are in the same format. This first equation, x plus y equals 5, is in standard form, but the second one's not. So what I'm going to do is put it into standard form. So now I have a new equation. I suppose it's the same equation, just rewritten. And now I have to solve x plus y is equal to 5. Well, it looks like we have the same number in front of my variables, but not the same sign. So maybe I want to multiply one of these equations by -1, so that way I can change the signs and add my equations together. When I do that, I get x plus y equals -4. And when I distribute this -1 into the second equation, I'm going to get -x plus -y equals -5. And now I can add my equations together. However, when I do that, x minus x cancels, so does y minus y. So I have nothing left on the left-hand side. And then -4 plus -5 is -9. All of my variables canceled, and I'm left with 0 equals -9, which is false, which means I'll have no solutions. So eventually on Thursday we're going to have a quiz, and there will be one problem where your variables are going to cancel and that you're going to get either no solutions or infinite solutions. Tonight's homework will have some of these no and infinite solutions on the assignment, but not every single one of them will be no or infinite solutions. So just be cautious of that. Otherwise, your homework is going to be posted on my Weebly. I want to make sure that you all give it your best shot. On those story problems at the bottom, I might count them as extra credit for now. You'll have them on your test, but not on the quiz that's going to be this week. So if you want to do them, you can do those for extra credit. The rest are due tomorrow. All right, have a good day.